Lesson 6 Binomial Theorem. Hello everyone, Dennis here. This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard. Don't forget to subscribe and press the bell notification button to stop missing out important updates from me. Binomial Expansion. A plus B to the power n. Now look at this expansion, a plus b to the power n. If n equals to 0, it will be a plus b to the power of 0 and the answer is 1. When n equals to 1, it will be a plus b to the power 1 and we get a plus b. When n equals to 2, we will get a plus b squared and it will be a squared plus 2ab plus b squared. I hope that this won't be not familiar with you because this is the quadratic expansion that you should have learned in elementary maths. Okay, when n equals to 3, you'll be a plus b cubed, and I hope you should know the answer because we have just learned this in the previous chapter, polynomial, and the answer is a cubed plus 3a squared b plus 3ab squared plus b cubed. Similarly, n equals to 4, right? It will be a plus b to the power 4. You should be able to get the answer, which we also have learned in the previous chapter, the polynomial. So the answer will be a to the power 4 plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the power 4. Now, let's copy down all the coefficients of the expansions here. So the first one is 1. The second one, the coefficient will be 1 and 1. The third row, the coefficient will be 1, 2, and 1. And the fourth row, the coefficient will be 1, 3, 3, 1. And the fourth row, the coefficient will be 1, 4, 6, 4, 1. Okay, from here, I hope that you can observe the pattern. And now you can guess what is the coefficients for n equals to 5. Alright, so let me tell you the answer first. It will be 1, then 5, 10, 10, 5, and 1. Okay, now how I get this number? Do you observe the pattern? Now let's look at these two first. It is actually the addition of these two numbers, 1 and 1. Okay, we go to the next one, the 3 here. It is also the addition of this 1 and 2. So we get a 3. Similarly for this 3, it is these two numbers, 2 plus 1, we get 3. Now we move on to the next level, right? This 1, 4. So it will be the addition of this 1 and 4 and we get this 5. Alright, so can you tell now when n equals to 6, what are the coefficients? Alright, so the first number is always 1. Then we know that 1 plus 5 equals to 6. Then 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. And the last number also is 1. Okay, so we can continue with the pattern. Even if the n is 20, we should be able to get the coefficients without needing us to expand the a plus b to the power 20 manually. Okay, so this can form a triangle and it is called the Pascal Triangle. Now, we have just seen Pascal Triangle in the previous slide. So let's talk about the Pascal Triangle's features. The first one is there are n plus 1 terms in the nth row. Okay, so let's say it is the third row, then there are 4 terms. If let's say it is 15th row, then we have 16 terms and so on. Okay, now the next one, each row begins begins and ends with 1. Alright, so if you observe carefully in the Pascal Triangle, each row, right, begins with 1 and ends with 1. So the next one, the triangle is symmetrical about the vertical line through its middle. Okay, so we get a isosceles triangle. The next one, the coefficient of each term can be obtained by adding the two nearest coefficients from the previous row. Okay, so I've shown you, right, how to get or guess the coefficients by adding the two numbers in from the previous row. We have just seen the binomial expansion a plus b to the power n using the Pascal triangle. Okay, but if you observe quite carefully, you see that there's a problem using Pascal triangle. So the problem is when n is getting larger, then we need to write many rows. Like for example, just now, right, when n equals to 20, then if you use Pascal triangle, we need to write 20 rows until we get the answer. So is there any way that we can expand the binomial expansion more effectively? Okay, the answer is yes, we have, which is called binomial theorem. So for binomial theorem, there's a formula for a plus b to the power n. So this is the formula, right? A plus b to the power n is equals to a to the power n plus n choose 1, a to the power n minus 1, b, plus n choose 2, a to the power n minus 2, b square, plus n choose 3, a to the power n minus 3, b cubed, plus continue until the middle term will be n choose r, a to the power n minus r, b to the power r, plus until to the last term plus b to the power n. Okay, you should remember this formula. Okay, now you might ask, why is the n choose r? Okay, so n choose r, actually you can press directly from the calculator if you know the value of n and r. But here is the formula for n choose r. Okay, the formula is n factorial over r factorial times n minus r factorial. Okay, which can be further simplified to this, right, which is n times n minus 1 times n minus 2 until the last one will be n minus r plus 1 over r factorial. Okay, so now let's look at some examples here. The first example, 5 choose 3. Okay, let's apply the first formula, which is this. Okay, n factorial over r factorial over n minus r factorial. So for this case, right, our n is 5. Okay, so it will be 5 factorial, and the r is 3, so 3 factorial, and n minus r will be 2 factorial. So it will be, for the factorial, actually it means is this 5 times 4 times 3 times 2 times 1. For 3 factorial, it will be 3 times 2 times 1. For 2 factorial, it will be 2 times 1. Okay, and from here we actually can cancel, right? 2 times 1, 2 times 1. So, and continue, right? We can get the answer, which is 10. Okay, so if we apply using the first formula, we can get the answer 10. Alright, okay, now let's look at the second example, 10 choose 4. Now let's apply the second formula. How we want to apply the second formula? Alright, so we look at, the answer is this, right? How we want to apply, now look at the 10 here and the 4 here. Okay, if this is 4, now at the top one, right, you start with 10. Okay, times with one number, 1 lower than 10, which is 9. Okay, and then the next one, right, 1 lower than 9, which is 8. Okay, we'll repeat the process, right? If this is 4, then we'll repeat 4 times. So for this case, this is 10, they will be 10 times 9 times 8 times 7. So 4 times 1, 2, 3, 4. Okay, if let's say 10 choose 5, then I need to add one more, which is 10 times 9 times 8 times 7 times 6. Right, so it's 5 times. Okay, now at the bottom, right, it is the 4 factorial here, which is 4 times 3 times 2 times 1. Okay, look at the formula here. It is r factorial. So our case r is 4. So it's a 4 factorial here. Okay, then the answer is 210. Okay, here another one is we have a few special example here. like n choose 0, right? So n choose 0, the answer is 1. N choose 1, the answer is n. N choose 2, it will be n times n minus 1 over 2. N choose 3, it will be n times n minus 1 times n minus 3, 3 factorial. N choose n, it is 1. Now, here are a few special cases for binomial theorem. When a equals to 1, then our expansion will become 1 plus b to the power n equals 1 plus n choose 1b plus n choose 2b square plus n choose 3b cubed plus continue into the middle term n choose rb to the power r plus until the last term plus b to the power n. You can see that we seems like ignore the first term a, right, because it is 1. Okay, and then if we want to find the r plus 1 term, so it will be t r plus 1, which is n choose r times a to the power n minus r, b to the power r. Okay, so this is a formula that you should memorize. Next, if you see that the question saying the term independent of x, it means that it is a constant term, okay, which means the power of x is equal to 0. Now, let's try to apply the formulas that we have learned just now. Okay, this example, okay, will allow us to find the coefficients of specific terms. Okay, write down the first 4 terms in the expression 1 plus 2x to the power of 7 in ascending power of x. Hence, find the coefficients of x cubed in the expansion 1 plus 2x plus 3x squared times 1 plus 2x to the power of 7. Here's the solution. Okay, from the expansion here, 1 plus 2x to the power of 7. Okay, so the a is 1. Then when we expand, we can get this, right, equals 1 plus 7 choose 1 times 2x plus 7 choose 2 times 2x squared plus 7 choose 3 times 2x cubed plus continue ... Okay, so now we can simplify this expansion, right? That 7 choose 1 is times 2 is 14, right? And 7 choose 2 times actually 2 square will be 84, and then 7 choose 3 times 2 cube will be 280, right? So the answer will be 1 plus 14x plus 84x squared plus 280 x cubed, and so on. Alright, now we move on to the next part of the question, right? So we want to find the coefficient of x squared. So for this expression, right, 1 plus 2x plus 3x squared times 1 plus 2x 7, right? So it means that 1 plus 2x plus 3x squared times 1 plus 14x plus 84x squared plus 280x cubed, and so on. Okay, now from here, in order to get x cubed, the 1 multiply with 280, x cubed, we get x cubed. So the coefficient will be 280, okay, x cubed. Now the 2x here will multiply with this 84x squared, and you get 168x cubed. The 3x squared here will multiply with this 14x, and we get 42x cubed. So the remaining multiplication will not get us any x cubed. So therefore, from here, we can add the coefficients, right? We'll get 490x cubed. Alright, so then the coefficient of x cubed will be 490. Okay, now you can try this similar example yourself. Write down the first 4 terms in the expression 4 plus x to the power 5 in ascending power of x. Hence, find the coefficient of x cubed in the expression 3x minus 5 times 4 plus x to the power 5. You can pause the video and try to do it yourself. Okay, here is the solution. Firstly, we want to expand this 4 plus x to the power 5. By applying the binomial theorem, it will be 4 to the power 5 plus 5 choose 1 times 4 to the power 4 x plus 5 choose 2 times 4 cube x square plus 5 cube times 4 square x cube plus dot dot dot. Right? So now we can simplify. It becomes 1024 plus 1280x plus 640x squared plus 160x cubed plus dot dot dot. Alright, so this is the expansion. Now we move on, right, to find the coefficient of the x cubed by expanding 3x minus 5 times 4 plus x to the power 5. Okay, it will be 3x minus 5 times 1024 plus 1280x plus 640x squared plus 160x cubed plus dot dot dot. Alright, in order to get x cubed, so now the combination will be, right, 3x times if 640 x squared, right, then plus negative 5 times if 160 x cubed. Alright, so only these two combinations will give us x cubed. So now we further we multiply the number. 3 times 640 becomes 1920, right? Negative 5 times 160 becomes negative 800. Okay, and we'll get 1120 x cubed. So therefore, the coefficient of the x cubed will be 1120. So do you get the answer correctly? Alright, so now let's look at another example to find the values of unknown coefficients. So this is the question. Find the value of k and of n given that 1 minus 3x squared times 1 plus kx to the power of 10 equals 1 plus 14x plus nx squared plus dot dot dot. Alright, so now here's the solution. From the expression given, 1 minus 3x squared times with 1 plus kx to the power of 10. Okay, so we apply the expansion, right? For the first one, 1 minus 3x squared, we will get 1 minus 6x plus 9x squared, right? Then for the second number expansion, right, we can apply the binomial expansion, which will give us 1 plus 10 choose 1 times kx plus 10 choose 2 times kx squared and so on. Alright, so now simplify it, we get this 1 minus 6x plus 9x squared times 1 plus 10kx plus 45k squared x squared and so on. Right, and then we expand these two brackets, we'll get 1 plus something, right, and x plus something, and x squared something. Okay, can you see, right? We start with 1 and x squared and so on. So now what times what, we get x. So if it 10k minus 6. Alright, the next one, x squared, it will be 9 minus 60k plus 45k squared. Alright, now we compare the coefficients, right? So the 10k minus 6 equals 14, right? How we compare? So this 10k minus 6, right, is the coefficient of the x, then it is 14. So 10k minus 6 equals to 14. Therefore, 10k equals to 20, k is 2. Next, right, this whole thing, right, 9 minus 60k plus 45k squared is the coefficient of the x squared. We compare the original equation, it is n, therefore n equals 9 minus 60k plus 45k squared. And we substitute the k value, which is 2, inside the equation, we get n equals to 69. This is how we get the value of k and n. Now, you can try this similar example yourself. Given that the first three terms of the expansion of 1 plus ax plus bx squared times 1 minus 2x to the power of 8 in ascending powers of x is 1 minus 13x plus 63x squared. Find the value of a and of b. You can pause the video and try to do it yourself. Okay, here's the solution. First, we want to expand 1 minus 2x to the power 8. By applying the binomial theorem, we will get 1 plus 8 choose 1 times negative 2x plus 8 choose 2 times negative 2x squared plus dot dot dot. Right, so you get 1 minus 16x plus 112x squared plus dot dot dot. Okay, so now we go to the expansion of 1 plus ax plus bx squared times 1 minus 2x to the power 8, which is equals to 1 plus ax plus bx squared times 1 minus 16x plus 112x squared plus dot dot dot. Okay, then now we can expand. We get the first one is 1 plus, and the second term is x, the third term is x squared. Now from here, what is the combination of the multiplication, right, which will give us x? Okay, so the answer will be 1 times negative 16. Okay, so which will be negative 16 plus a. So 1 times negative 16, we get x. Ax times 1, we get x as well. So that's why it's negative 16 plus ax. How about x squared? For x squared, it will be 1 times 112. And next one, right? Ax times with negative 16x. So we get negative 16a. Next one, bx squared times with 1. So that's why we have this plus b x squared. Alright? Okay, now the next step is we can compare the coefficients with here, right? So for the x, negative 16 plus a equals negative 13, which is this one. So from here, we can solve this equation. We get a equals to 3. Now, the next one, 112 minus 16a plus b equals, right, 63, which is this one. Okay, we substitute a equals to 3 inside this equation, and the 112 move to the right hand side. Simplify, and we get the b equals to negative 1. Do you get the answer correctly? Okay, now let's look at the application of factorial. Here's the example. Find the value of k and n given that 1 plus kx to the power n equals 1 plus 48x plus 1008x squared plus dot dot dot. Okay, here's the solution. 1 plus kx to the power n equals, right, apply the binomial theorem formula, we get 1 plus n choose 1 kx plus n choose 2 kx squared and so on, right? So simplify, right? Now the problem here is that we do know what's the value of n. Okay, so we have to apply the formula of the this factorial, right? For n choose 1 is 1, is n, right? So it becomes n times kx. N choose 2, right, will be n times n minus 1 over 2 k squared, right, x squared and so on. Okay, we just need to expand until 3 terms because over here it is given us the 3 terms. So the next step we want to do is we just compare the coefficients. So the nk equals to 48, right? So nk here and 48 is here. So they are the same because they are the coefficient of the x, right? And k will be 48 over n. Next, we compare this whole thing, right? N times n minus 1 over 2 k squared, it is equals to 1008 because both of them are the coefficients of the x squared. Alright, so now I can substitute the k, right, which is 48 over n inside the equation. Then we can simplify, right? So this is what we get. At the end, the answer is n equals to 8. Right? So once we get n equals to 8, then my k will be 48 over 8, and the answer is 6. So we can make a conclusion, k equals to 6 and n equals to 8. Now, you can try this similar example yourself. In the expansion of 3 plus 2x to the power n, the coefficients of x squared and x cubed are in the ratio of 3 to 4. Find the value of n. You can pause the video and try to do it yourself. Here is the solution. First, we want to expand 3 plus 2x to the power n using the binomial theorem formula. So it will becomes 3 to the power n plus n choose 1 times 3 to the power n minus 1, 2x plus n choose 2 times 3 to the power n minus 2 times 2x squared plus n choose 3 times 3 to the power n minus 3 times 2x cubed plus dot dot dot. Then we can further simplify, right? So now for n choose 1, it will be n. Okay, so now remaining the same, we just separate the 2x becomes 2 times x. The next one, n choose 2, will be n times n minus 1 over 2. Okay, and we want to take this 3 to the power n minus 2 becomes 3 to the power n over 3 square. So this 2x square becomes 4x square because here 2 square becomes 4, right? And then n choose 3 will be n times n minus 1 times n minus 2 over 3 times 2. 3 to the power n minus 3, right? It will becomes 3 to the power n over 3 cube. So here 2 cube will be 8 and become 8x cube. Right? So from here we know that the coefficient of the x squared is equal to 2n times n minus 1 over 9 times 3 to the power n. Okay, why is it so? Okay, here 9 is because it's 3 square, right? And 2 and 4, right? You can cancel, become 2 here. So that's why you get 2n times n minus 1 over 9 times 3n. 3n is here. Okay. Now the next one, the coefficient of x cubed. So from here we can simplify actually, right? It becomes 4n times n minus 1 times n minus 2 over 81 times 3 to the power n. So the reason is because from here the 2 can cancel with the 8 becomes 4, right? So that's why you have the 4 here. So here 3 cube times 3, you get 81. So the remaining is the same. You just copy n minus 1, n here, n times n minus 1 times n minus 2. Okay, so this is the coefficient of x cubed. Now the question gives that the coefficient of x squared and x cubed are in the ratio of 3 to 4. So that's why, right, this whole thing, right, equals 2n times n minus 1 over 9 times 3 to the power n to 4n times n minus 1 times n minus 2 over 81 times 3n equals to 3 to 4. Okay, remember the concept of ratio, right? The ratio symbol can change to division, right? So 3 to 4 become 3 over 4. So for mathematically, the division we can change to multiplication, and reciprocal for this fraction. So it becomes times 81 over 4n times n minus 1 times n minus 2 times 3 to the power n equals 3 over 4. And from here, we can simplify, right? So the 3n cancel with the 3n, n minus 1 cancel with this n minus 1, 9 times cancel with 81, so 81 becomes 9, right? So 2n cancel with 4n, so 2 here at the bottom, right? So I think everything has been simplified. Then the it becomes 9 over 2 times n minus 2 equals 3 over 4, right? And 2 can cancel with the 4, becomes 2 at the bottom here. 3 and 9 becomes 3, right? And we can cross multiply. 3 times 2 becomes 6. So n minus 2 equals to 6. Therefore, n equals to 8. Okay, so do you get the answer correctly? Right, now let's look at application of general term formula. So here's the example, right? Find the term independent of x in the expansion of x squared plus 1 over x to the power of 12. So this is the solution. So t r plus 1, n choose r, a to the power n minus r times b r, right? So we have seen this formula in the previous slide. Okay, so this is to find the r plus 1 term in a binomial theorem. Okay, so for this case, right, the n is 12, which we get from here. Okay, and then our a is x squared, our b is 1 over x. So we apply all this inside the formula, right? We get 12 choose r times x squared bracket, then 12 minus r, another bracket, 1 over x to the power r. All right, and then we can open the bracket here, right? Becomes x to the power 24 minus 2r, and for this 1 over x to the power r, right, we change it to the indices form, which get us x to the power of negative r. Okay, then from here, right, we apply because they are the same body, right, we can add the power together. So we get 12 choose r, x to the power of 24 minus 3r. Okay, from here, right, the question wants us to find the term independent of x. So what does independent of x mean? Right, it just means that the power is 0. So this is the power of the x. Okay, since it is independent of 0, therefore this 24 minus 3r will be equals to 0. Okay, then we solve this equation. 3r equals to 24, hence r is 8. So from here, right, the term independent of x will be equals 12 choose 8. Okay, we go back to the equation here, right? So 12 choose 8. Then and because the power is 0, so this is the term, which is 495. Now, you can try this similar example yourself. Find the coefficient of x to the power 5 in the expansion of x cubed minus 1 over 2 x squared to the power of 10. You can pause the video and try to do it yourself. Here's the solution. So from x cubed minus 1 over 2 x squared to the power of 10, we know that the a is x cubed, the b is negative 1 over 2x squared, the n is 10, and the r is 5. Therefore, the formula tr plus 1 equals n choose r, a to the power n minus r, b to the power r. Just substitute a, b, n, and r into the formula. We get 10, t 5 plus 1 equals 10 choose 5 times x cubed to the power of 10 minus 5 times negative 1 over 2x squared to the power of r. Okay, now from here you need to be very careful, especially you see the negative value, the negative here. Okay, so you can break it, right, treat it as multiply with negative 1, so it will be negative 1r. Okay, and then from here 10 choose 5, the answer is 252. So over here, right, we can open the bracket here. 10 minus 5 is 5, so 5 times 3 is 15, so it's x power 15. Okay, and then here 1 over 2x squared. Okay, over here we can break it into half, right? So this is 1 over 2, okay, to the power r, and then this is x negative 2 times to the power r. Okay, so next step. Now what you need to do is, right, you need to separate the coefficient parts and the x parts. Okay, so the coefficient part, right, all are the constants. So you have the 252, negative 1, and half. So these are the constants. Okay, and then this is the x part. So once you get this, right, so 15 minus 2r, why is it big? So because here this x power 15 and this is negative 2r. So that's why when you combine, it becomes x to the power 15 minus 2r. Next step, we compare the power of x. So we have this 15 minus 2r, and we want the power is 5. So that's why 15 minus 2r equals to 5. You solve this equation, the r is equals to 5. Okay, so once you get the r equals to 5, we substitute the x equals to 5 into the coefficient part, as I said just now, right? So this is the coefficient part. Okay, it becomes 252 times negative 1 to the power r times half to the power 5. Sorry, negative 1 to the power 5 times half to the power 5. Okay, so you can see that everything is constant. So you press calculator, you get the answer is negative 63 over 8. Okay, so do you get the answer correctly? Now, let's discuss the applications of binomial theorem. You have seen several examples of the binomial expansion and binomial theorem. Alright, you might be wondering, right? The question is, why do we want to learn this chapter binomial theorem? Okay, and you might think that the formula for this binomial theorem is very long, very difficult to memorize, and we have already the calculator. So actually, why do you still want to learn binomial theorem? Alright, so now this is the question, why do we want to learn binomial theorem? Okay, now let's recall first, right? If we know, right, 2 cube, the answer is 2 times 2 times 2, right? Actually, we have learned this chapter in the indices chapter, right? It will get us 8. So how about this? If I want to find 2.1 cube, right? So from here, we know that it is 2.1 times 2.1 times 2.1. Okay, so if we use calculator, so the calculator will give us the answer is 9.261. Alright, now, without using calculator, in order to get the answer for 2.1 cube, we have to perform the operation manually. Right? So what if the number gets more longer? Alright, so what do I mean? For example, if I want to find 2.123 cube, how about this 2.12345 cube? And how about the power gets larger? Right? So for example, right, 2.123 to the power 5, 2.12345 to the power 12, 2.12345 to the power 20. So it will be very tedious, right, to calculate this number manually, right? I don't say that it is not possible to calculate manually, but it will be very tedious and very high chance if we do it manually, we will make mistake, so we get wrong answer. So now let's use binomial theorem to calculate this number, right? 2.123 to the power 5. So we can break this number into two parts, which will becomes 2 plus 0.123 to the power 5. Okay, where the a is greater than 1 and the b is less than 1. So now, based on the binomial theorem, right, the expansion will becomes 2 to the power 5 plus 5 choose 1, 2 to the power 4 times 0.123, plus 5 choose 2 times 2 cube times 0.123 square, plus 5 choose 3 times 2 square times 0.123 cube, plus 5 choose 4 times 2 times 0.123 to the power 4, plus 0.123 to the power 5. Okay, and we really go and find the answer, right? For 2 to the power 5 is 32, and the second term, right, it will be 5 times 16 times 0.123. The third term is 10 times 8 times 0.015129, and continue, we get this number and this number and this number, right? Now, what do you notice? Okay, notice that, right, the power of 2 is descending. Yes or no? So the power here, this is 5, then 4, 3, 2, 1, and 0. Okay, so the power of the 2 here, right, is decreasing. Right now, the value is getting smaller. When the power of 2 is decreasing, right, can you observe that the first one with 32, then 16, 8, 4, and 2. Okay, so the next one, right, the power of 0.123 is increasing. So look at the first one, 0.123 is power 1, then power 2, power 3, power 4, and power 5. So when this 0.123, right, the power is increasing, the value is getting smaller. Okay, observe, right, the first term is 0.123, the second term is 0.015129, the next one 0.001860,867, and continue getting very, very small. Okay, so when we look at the number behind, right, or the terms behind, when the two small values, right, multiply together, the result will be even smaller. Okay, hence the terms behind are getting less significant, right? So now we do not have to calculate all the terms. We just need to calculate the first few terms and still can get quite accurate results. Okay, so let's calculate the first three terms only, right? 2.123 to the power 5. Okay, just now we expand, we get 32 plus 5 times 16 times 0.123 plus 10 times 8 times 0.15129. Okay, and continue, right? We can ignore the term behind and we just need to add these three numbers. Okay, the answer is 43.05032. Okay, or we round it to three significant figures, it will be 43.1. Okay, so now you can take out a calculator and calculate the exact value. 2.123 to the power 5. The answer is 43.1270717. Alright, so can you see that, right? If you use binomial theorem, right, the answer is very, very close to the exact value. Okay, so which is also 43.1. The more terms we calculate, the more accurate the results. But it will be more tedious. So we do not need that accurate as the numbers behind are getting less significant. Now let's look at one example here, right? Write down the expansion of 1 plus p to the power of 6 in ascending power of p. Hence, find the first three terms in the expansion of 1 plus 2x squared to the power of 6 in ascending power of x. So use your result to find the value of 1.002002 to the power of 6 correct to 6 decimal places. Here's the solution. Okay, using the binomial theorem, right, we can expand 1 plus p to the power of 6 equals 1 plus 6 choose 1 p plus 6 choose 2 p squared plus 6 choose 3 p cubed plus 6 choose 4 p to the power 4 plus 6 choose 5 p to the power 5 plus p to the power 6. Okay, and we get this 1 plus 6p plus 15p squared plus 20p cubed plus 15p to the power 4 plus 6p to the power 5 plus p to the power 6. Right, so we answer the first question. Now let 1 plus p equals 1 plus 2x squared because we look at the expansion that we want to expand. Right, so 1 plus 2x plus 2x squared, right? We treat this as the p. So now we just substitute, right? Whenever we see the p from this expansion, right, we just substitute, it becomes 2x plus 2x squared. Therefore, it's 1 plus 6 bracket 2x plus 2x squared plus 15 bracket 2x plus 2x squared. Okay, and we get this 1 plus 12x plus 12x squared, right, plus 15 times 4x squared, and so on. Okay, and simplify, I will get 1 plus 12x plus 72x squared plus dot dot dot. So now go back to this question, right? 1 0.002002 to the power of 6, okay, we can actually break it into 1 plus 2 times 0.001 plus 2 times 0.001 square, then outside bracket to the power of 6. Alright, you can compare this with this equation, this expression, so they are same, right? So we can just substitute the x to be 0.001. Right, so using the answer here, right, whenever I see the x, it will be 0.001, 0.001. Okay, so then I'll get the answer is 1.012072. So this is 6 decimal places as required by the question. Okay, you can try this similar example yourself. Obtain the first 4 terms of 2 plus p to the power of 7 in ascending power of p. Hence, estimate 2.01 to the power of 7. Find the coefficient of x cubed in the expansion of 2 plus x squared over 2 to the power of 7. You can pause the video and try to do it yourself. Okay, here is the solution. For 2 plus p to the power of 7, when we expand using Binomial Theorem, we'll get this 2 to the power of 7 plus 7 choose 1 times 2 to the power of 6 times p plus 7 choose 2 times 2 to the power of 5 times p squared plus 7 choose 3 times 2 to the power of 4 p cubed plus dot dot dot. Okay, we just need to write down the first 4 terms and simplify. We'll get 128 plus 448p plus 672p squared plus 560p cubed plus dot dot dot. Okay, now move on to the next question. Estimate 2.01 power 7, right? We can break this number into 2, which is 2 plus 0.01, which means the p is 0.01. So what we need to do is we need to substitute whenever we see the value of p, whenever we see the p, you substitute 0.01. Okay, from here, right, I will get this, and then the rest I just calculate. The value will be 132.54776. Okay, lastly, right, we have this 2 plus x squared over 2 to the power of 7. Okay, so when expand, right, we will get this. Okay, so what we do is we are using the same expansion here. Whenever we see the p, we will substitute with x plus x squared over 2, right? So that's why 128, okay, plus 448, we have the p here, becomes x plus x squared over 2. So 672p squared becomes 672 x plus x squared over 2 square, right? And plus 560p squared, p cube becomes 560 times x plus x squared over 2 cube, dot dot dot. Alright, then we simplify, right? And okay, we want to find the coefficient of the x cube. So which is, when we look at this whole thing, right, we get 672 from here, right, plus 560. Okay, and the answer is 1232. Okay, so do you get the answer correctly? Alright, that's all for this video. Thanks for watching. Do you have any questions or thoughts to share? Feel free to write it down in the comment. I would love to hear from you. Do you like this video? Please don't forget to like it and share it with your friends. Until then, I will see you in the next video. Have a great day ahead.